All right, let's look at the second partial derivatives. Let's say you have a function z equals f of x comma y, and we want to take a partial derivative twice, right? There are actually four kinds. We can take the second partial with respect to x twice, right? And we can talk about the second partial both with respect to y. Or you can take the partial derivative with respect to x, then you take the partial with respect to y. All right, you might want to pay attention to this. This might be a little bit confusing. All right, so when you use this notation, the first partial derivative comes on the right-hand side. So this is the first one, and this is the second partial derivative. But so it goes from right to left. But if you look at this notation, the first partial derivative done is with respect to x. And this is the second partial derivative. So in this notation, it goes left to right. Right? So you just have to pay attention. So you have a partial derivative z with respect to y first, and then with respect to x. Then the other notation, you would have to write f sub yx. All right, so let's take a bunch of partial derivatives. All right, so let's find first, we have to take the first partial. All right, so I'm going to take the partial with respect to x, and I'm going to take the partial with respect to y. All right, so with respect to x, all right, so y is a constant. Derivative of that, 7x cubed is 3 times 7 is 21, x squared. Here, negative 12y is a constant, so derivative of x is 1, so you have a 12y, because that's just a constant. All right, here, if you take the derivative of a constant, it's 0, so it goes away. So this is first the partial with respect to x. So here's the partial with respect to y. All right, so this is a constant, derivative 0 with respect to y. So partial of this, so you have a negative 12x is just a constant. Derivative of y is 1, so you get that. All right, partial of y cubed with respect to y would be 3y squared. All right, then we can look at its second partial. All right, so here we can go couple of different ways. We can do the second partial with respect to x again. So we're going to write it this way. All right? So you have, all right, partial of that with respect to x is 42x. And this is just a number, so this is it. So when you do a second partial with respect to x first, but then we're going to do with respect to y. All right, then here, 21x squared is just a number, so partial derivative with respect to y is 0. Partial of negative 12y with respect to y is negative 12. All right, we got that. All right, so two more kinds. So you take the partial with respect to y first, then we're going to take the second partial with respect to x. So you do y first, then x, right? All right, so we take this with respect to x, it's going to be negative 12, and partial with respect to x is 0, so it's just going to be that. And the second partial of z with respect to y twice, right? So this is going to be partial of the first term is 0 because it's a constant. Partial of 3y squared would be 6y. All right, so those are all four kinds of second partial derivatives of this given function of two variables. All right, that's it. I hope that this was clear.